watching the video, then you can see the three-dimensional coming out of the board here like this. So we're going to use all our techniques we learned this unit to try to solve this. Whoops, what the heck just happened here? So I'm going to label this equation 1, equation 2, and equation 3 so we can keep track of it. So what's the preferred method of solving? So elimination, a lot of people agree. Okay, so we're going to do elimination, and we're going to try to eliminate something. Actually, can anybody see something we could eliminate just even the way it's written? Oh, the bottom two lines, you could eliminate the y? Is that what you said? Or you could even eliminate the z's here with these two. Guess what? We're going to do it all. Okay, so we're going to start doing 1 and 2. Okay? And then I'll do 2 and 3. You'll see why we have to do all this. So, and again, if the 5 is not written on the other side of the equal sign like the other equation, you need to do that. So 2x minus y plus z equals 0, and x plus 2y minus z equals negative 5. All of these have to be lined up to do elimination, right? Okay, so do you see that the z's eliminate? So then we get 3x, I'll draw a line, 3x plus y equals negative 5. And I'm going to call this equation 4. Okay, now I'm going to go back to what somebody else said. Now, we could do 2 and 3 and eliminate the y's. Do you see this newly created equation 4 only has x's and y's? So if we want to get somewhere, we need to create another equation with no z's in it. Okay? Does that make sense? It's like plotting a, chess move. Do you see? This looks like the equation 4 looks like the ones we're used to when we were solving in this unit. So now we can't use 1 and 2 again because we won't get anywhere. We got to use 1 and 3 or 2 and 3 to eliminate a z now. So which one do you want to do? Doesn't matter. It really doesn't. Anybody? Anybody? Make a decision. Either going to do 1 and 3 or 2 and 3. 2 and 3. Okay, we're going to use 2 and 3 this time. So we're going to try to eliminate z. So in order to eliminate z, what would I have to do to equation 2? Times it by 2. Okay, so I'm going to times equation 2 by 2. So 2x plus 4y minus 2z, and then I have to move the 5 over at the same time and times it by 2. Is everybody good with what I did for equation 2? I times it by 2 and move the 5 over to the other side. Equation 3 is good to go. Equation 3 is good to go. 3x plus 2y plus 2z equals 14. Yes? So does everybody see? I'm now going to eliminate my z's when I do the elimination. Yes? So 5x plus 6y equals 4. And that will be my equation number 5. Guess what we're going to do now? We're going to put 4 and 5 together. And this looks like one of your equations that you're used to. Now, if I put 4 and 5 together, we want to eliminate again, right? So what do you want to do to eliminate? Times what? Eliminate the y. Okay, and times it by negative 6. So I'm going to times 4 by negative 6. So here's my new 4. We're going to times that by negative 6. So negative 18x minus 6y equals positive 30. Is everybody good with what I did? Now I'm going to, huh? We're good? Okay. I thought maybe I made a mistake or something. Number 5. 5x plus 6y equals 4. Now we're going to eliminate. Eliminate. Then we get negative 13x equals 34. What? This is that's a 5. Uh-oh. Uh-oh. Did we make a mistake somewhere? It's not going to be, I don't want to use ugly things here. X equals negative 34 over 13. Yuck. Okay, so once we know what x is, does everybody see we can easily solve for y? Maybe not easily with an ugly fraction like this, but anyways, so it depends on what you want to put it in. I think I'm going to put it here because that's an easy one to solve y. So do you see? 3 times negative 34 over 13 plus y equals minus 5. And so y equals, so maybe I'll just multiply this first. So if I multiply 34 times 3, I get 102, yes? Minus 102 over 13 plus y equals 5, and that's 5 over 1. So what's my common denominator going to be? 13. So I need to multiply this by 13 over 13 in the form of 1. So y is going to be 65 over 13 plus 102 over 13. So I get 167 over 13. I assume that's not divisible. Does it work out nicely? Yeah. Court. Okay, so sorry, this was a negative 5 there. Oh my gosh. Let's try this again. So this was a negative 5 there, which means it's negative 65. So what's negative 65 plus 102? There we go. So that is what? 37. 37 over 13. Yes? Okay, so now we have y is 37 over 13. X is negative 34 over 13. Now we got to figure out what z is. So how am I going to do that? Go back to the original. Which one do you want to use? Looks like 1 is pretty easy. No? So 2 times, what was my x again? Negative 34 over 13. Subtract y, which was 37 over 13. Plus z equals 0. So does everybody see what I did there? Okay, so now I'm going to multiply this, and what do I get there? What's 2 times negative 34 over 13? Negative 68 over 13. Minus 37 over 13 plus z equals 0. What do I get when I put that together? I get 68 and 37, 15, 105, yes? So if I move that over, I get z is 105 over 13. Okay. So let's check our answers, but we're going to use our calculator to do this, okay? So remember, it has to work in all three, yes? Because it's negative on this side, when I move it over to this side, it would be positive. Okay, so let's get our calculator. And so we checked our answer, and how are we supposed to state our solution? It's going to be negative 34 over 13, comma, 37 over 13, comma, what was my 105 over 13? Okay, let's try it. Let's try this one. Hopefully this works good. So, does everybody see this is actually set up for substitution? Kind of nice, hey? Do you want to substitute it into here? So I'm going to number it 1, 2, and 3. So I'm going to substitute 3 into 1. Okay? So 2 times 6 minus y minus 5z plus 5y minus z equals 10. Does everybody see what I did? I substituted the x into number 1. So then I get 12 minus 2y minus 10z plus 5y minus z equals 10. Sometimes on my z's I put a line through it to make sure I don't think it's a 2 later on. You may want to do that. Do you see what I'm saying? I did that there without even thinking, actually. Okay, so then if I combine the like terms here, I get 3y minus 11z equals minus 2. So this is going to be equation number 4. Check to make sure that's all good. Everybody agree? Yeah? Okay. So now we're going to take number 3 and substitute it into number 2. So we're going to take 3 and substitute it into number 2. So 3, instead of the x, now I'm writing 6 minus y minus 5z, minus y plus 4z equals negative 5. All right. So then we're going to multiply this out. I get 18 minus 3y minus 15z minus y plus 4z equals negative 5. Girls? So I'm going to combine the like terms. So 3y minus 3y and minus y is minus 4y. And then the 15z is negative and the 4z is positive. So that makes negative 11z. And then I'm going to move the 18 over to the other side. So that makes negative 23. Thank you. And that's my equation number 5. So does everybody see? Equation 4 and 5 only has y's and x's. Now I'm going to put them together. How would you like to solve that one? Ooh, it's nicely set up for something. Look at 4 and 5. What is it? Yeah, no, times 1. Eliminate them, but you'd have to switch one of the signs, right? Yeah. Okay, so I'm going to put 4 and 5 together. I'm going to leave 4 alone. 3y minus 11z equals minus 2. And I'm going to switch the signs of number 5. So 4y plus 11z equals 23. Eliminate. Beautiful. And it's going to work out nicely, too. 7y equals 21. Y equals 3. Yay! Okay, so now that I know y is 3, what do I do? Plug it into where? Which equation do I plug it in? Not 2. Yeah, 4 or 5. One that only has a y and a z, because if I plug it into the originals, that has an x, y, and z. Then I'm not going to get anywhere, right? Okay, so I'm going to plug it into number 4. So 3 times 3 minus 11z equals minus 2. So that's a 9. If I bring the 9 over to the other side, what do I get? Negative 11. So z equals 1. Oh, that's nice. That's nice. Hey? It's too bad our first example was so ugly. Okay, now we're going to plug those in. Where? Yeah, I think the third one's the best because that tells you x equals, right? So we're going to plug it into 3. So x equals 6, subtract y. Y was 3. Subtract, does that say 5z? Okay, so 5z, so 5 times 1. So 6 minus 3 minus 5. So what do I get? Negative 2, very good. So my point of intersection is negative 2, comma 3, comma 1. Should we check it? We're good? Okay, let's try the next one. Let's try the next one. That's my last example. Yes? Okay. What? There's another one? I have 4 examples. I got to get rid of. Okay, you guys try example 3. So I'm going to label this 1, 2, and 3. Which one did you start with? Who started with something? Gavin, what did you start with? 1 and 2. And what did you want to eliminate in 1 and 2? Y. Okay, so 1, you're going to keep the same. X plus 2y plus 3z equals 5. And then what do you do with number 2 to eliminate? Times by minus 2. Very good. So make sure on your elimination you line it up. So don't put negative 2y underneath the x, right? Minus 2y minus 8z equals, we're timesing it by negative 2, right? So this is positive 10, yes? Yes? Okay, so let's eliminate. We get x minus 5z equals 15. This will be equation 3. Do we have another equation that just has x's and y's in it? No. Oh, question 4. Thank you. Thank you. Oh, I'm losing it today. Okay, equation 4. Okay, so we don't have one that just has x's and z's. So now, what do you want to do next? How about we do 2 and 3 and eliminate the y's again so that we have x's and z's. Do you see that? It's kind of like a chess game. You got to figure out what you're doing here, right? So 2, what would I have to do to 2 to eliminate the y's? Times it by 6, negative 6. So negative 6y minus 24z equals 30. And then this is 5x plus 6y equals 43. Okay, does everybody see what I did there? This is equation 3. So I times equation 2 by negative 6 because I'm going to eliminate the y's. And then I get 5x minus 24z equals 73. And that's equation number 5. So do you see now, equation 4 and 5 has x's and y and z's, and we can put that together to solve. 2 equations, 2 unknowns will work now. Yeah? Okay, so what's set up good to eliminate here, you guys? The x's, yeah. Multiply 4 by 5. So 4 is, I guess, a minus 5, hey? So minus 5x plus 25z equals minus 65, is that right? Nope, minus 75. I don't know how to multiply. Minus 75. Somebody check my math here. Okay, and then this is 5x minus 24z equals 73. Well, that looks beautiful, doesn't it? Eliminate. Bam. What do we get here? Z. 1z equals minus 2. So we got my x. We got my z. So now I have to figure out my y. So what do you want to substitute it in to figure out your y? Oh, we only have our z so far. Sorry. Well, technically, we could, if we have our z there, we could figure out for y for number 2. And once we have our y, we can figure out our y from there. Did you see that? It's up to you if you want to do that. Okay, so I'm going to do that into number 2. So y plus 4 minus 2 equals minus 5. So this is negative 8. So y equals 3. So now I'm going to take that, and do you see in equation 3 I only have an x and a y? So if I take that and put it into equation 3, I get 5x plus 6 times 3 equals 43. So this is 18. So if I subtract 18 from 43, what do I get? 25? I do get 25. So 5x equals 25, so x equals 5. So my point of intersection is 5, 3, -2. Okay, so this is like the previous example where you have to use combinations of ones to eliminate, right? So do you think you can try that? Do you want to try it on your own?
Yeah, I guessed I got it.
You did not, really? Okay, let's see. Okay, so yeah, let's try to solve this algebraically. So let's do what? 1 and 3? 1 and 3. No, sorry, let's do 2 and 3. 2 is y plus z equals 7, and 3 is x minus z equals 2. X plus y equals 9. Oh, I got x plus y equals 9.
So our way is better. Oh, we win. So you should just guess.
That, you guys, what does that mean? Huh? No. What does that mean?
It's an infinite or something.
Yeah, it's an infinite solutions. So any combinations should work here. So that's why it was so easy to guess.
Yeah, we're just really...
No, because look, if I take 2 and 3 and then I get 1, this is an infinite loop is what's happening, right? So let's just think of, so you said x is what again? Yeah. Z is 4. And y is 3. Okay, so let's come up with another concoction then, because we know there's infinite number, right? So let's go x equals 0, y equals 9. So then what does z have to be? Look, if that's 0, what would z have to be? -2. So let's see if that works. No, it works. I could come up with this all day, right? That's why I'm saying, that's why it was so easy to guess. It's an infinite amount that'll work, right? Anything that adds up to 9, you can solve the other one and it'll work. So for instance, okay, so you're saying x is 4 and y is 5? So if x is 4 and y is 5, x is 4, so what would that, z would have to be 2. And check, it works. It works in all of them. So, where does,